Hi, everyone. Thank you so much for joining this afternoon. I am Anita Adusumali, Program Manager from the Azure Networking team. And I have here joining with me Mario Lopez, Program Manager from the Azure Networking team as well. We've been both working in the network security area for the last few years and probably met some of you as well. We are here to share our learnings and also share more details about the announcements Yusuf had made yesterday. You may have seen that Azure Networking has had many security announcements in the last few days. So we'll go over all those details today. So in the session, we will cover the network security challenges you may have in the cloud. Today, a lot of your organizations are moving your mission-critical applications into cloud. You're trusting us with your end-user data and your critical workloads. That's pretty much your business trust on us, and that's a lot of responsibility for us. And we take that responsibility very seriously. And that's what is leading to the kind of security announcements that you're seeing in the Azure networking space. Now, application trust is not just networking, but networking is a core component of ensuring that your data is secure and the data can be trusted to be within your networks in the cloud. So we'll start by looking at the challenges and answering some of the questions that you may have that you see here. Then we'll move on to which network security offerings can be used for what. Cloud security is very varied, and we have many different exploits, different ways your applications can have security threats. How many of you have the questions that you see on the screen? Can I see a raise of hands? That's about 20–30% of the crowd. And I'm glad to say that I'm not seeing more hands up. It means that likely your workloads are already mature in the cloud, that you're probably past that shift of initial wave of questioning whether cloud is the right platform for you or Azure is the right platform for you. So we will address the questions that you may have, whether you're planning in the networking area, whether it's your kickstart, or whether you've already had a mature workload. We'll look into how to layer our network offerings and how to scale them up as your workload scales. A few years back, we've had discussions with many of you where when we looked at your architectures, it was just mostly monolithic workloads. It was mostly three-tier architectures, a specific virtual network that is extended from your data center, a few virtual networks, if you may. And it's mind-boggling to see how far we have come and the kind of workloads that all of you are spinning up on Azure these days. It's fully dynamic. It's containerized. It's going closer to your end users. If you look at Azure, we have now 54 regions of coverage, bringing your workloads and data closer to your end users. We are building up more and more edge sites where we can get your data to your end users at a very fast pace. That means that network perimeter that you thought about as virtual networks or defined boundaries are no longer applicable to what we define as cloud today. That perimeter is changing. It's no longer, this is my network, and this is how I'm going to actually secure that perimeter. It could be closer to an edge site. It could be closer to one of your end user laptop machines, right? So how do we go about really looking at cloud security from a new wave point of view, right? That's one concern. And attack vectors are really changing based on your application requirements. If you're building web applications, you will have different levels of exploits. You may have SQL injection, cross-site scripting, and so on and so forth. You'd have to think about different sort of exploits. If you come to the cloud building with Azure services or SaaS services, you may have different sort of exploits. If you're building applications that are using IaaS as a direct extension to your data centers, you may have different exploits. So it's not one size fits all answer. It's not like one solution to everything. And you may have to ask this question as your workloads evolve many, many times, and as your perimeter changes many, many times. So your applications are changing, and so the cloud security is changing. But more importantly, I think as organizations, we all, it's a collective learning really, right? Like we as Azure are also learning from your workloads. And we have to ask ourselves, are we giving the right measures for you? And similarly, I want you to ask yourselves, have we really secured the boundaries every time your data moves from one perimeter to the next? So when you think of coming to Azure, if you're kickstarting your workloads, mostly you would start by defining your own virtual network. That's your private network in the cloud. You would extend your on-premises directly with a secure connection, either ExpressRoute or VPN gateway. You would have address space defined, and if you want much more segregation, you would start putting subnets in the virtual network. Now, this is a lot more dynamic than what you would do in the data centers. You can spin up VNets very fast and tear them down. This is all done in the software for us. And so your network can really grow with your workload requirements. And we also have what is native to the cloud, multiples of Azure services. These offer complex mechanisms to run compute workloads or data workloads in a way that we manage the workloads for you. So this gives you the power to actually spin up, let's say, a Hadoop cluster in a few minutes. You don't have to actually have expertise to build that from scratch, right? And that's just an example. We have a plethora of services now for ML and AI, and the service list is only growing. And you may also build applications that are web-facing for your internet end users. So you start with this virtual network, but as your workloads may grow, or your network requirements may grow, you may bring up new VNets. And these virtual networks may be paired with your, paired with your existing virtual networks. And you can keep expanding on these as your network demands grow by peering more and more of these virtual networks. And you can continue scaling to multiple regions. So you may have your end users in a region too. You can bring VNets up in those regions, pair them into central VNets, and you may want to do that for multiple reasons, hub and spoke architectures that you're very familiar with now. And you may also have other direct connect sites that may link to these regions. But as you look at these virtual networks, the kind of offerings that we give are a few basic ones that you see on the screen. We have many familiar firewall offerings from your on-premises that partner with us in the NVA ecosystem, but also some very native cloud offerings. We have the network security groups that are FITUple rules and ASGs and so on and so forth. We will cover each of those in detail. Depending on your requirements and your workloads, you can pick and choose any of these. So how do you go about picking the right ones? How do you ensure you have the right security models? To pick the right security model, you really need to look at the application patterns that your virtual network is set up with. You may start by just as a direct extension of your on-premises, in which case you're only dealing with private traffic. You're only segmenting traffic in a way that in case your virtual network gets exploited, you don't want your on-premises to take the same exploit. So you may just have some segregation, some rules to make sure that you have the right levels of layering. But as you bring in Azure services, it could change your ways of how you think of applying security. And similarly, once you put the web applications, you have a whole lot of new products or concerns, and so it brings up a new security offerings into space. And finally, we have the micro-segmentation for NSGs, ASGs, and UDRs. So in the next half of the session, we will look at each of these access patterns and how each of these can help secure your workloads. And really, the way to look at the cloud security is once you have the base pattern established, once you know which ones to put where, you can layer and scale the same techniques over and over again as your network grows. So starting with Azure services, and we're only starting with this topic because this is something that's native to the cloud. Rest of the mechanisms are similar to what you have in on-premises. So this is something that we hear a lot of you share concerns about, that Azure services have public IPs. Why does that matter? When you extend your on-premises to the virtual network in the cloud, that's still your private network. You can spin up VMs that just have private IPs, and that's just can be as secure as your on-premises. There's no requirement that you have to put public IPs in your virtual networks. However, once you start using Azure services, as many of you may be familiar, they all have public IPs. And so the public IPs mean a few things for your networks, right? So the minute you're introducing Azure service into your VNet, it means a few things for your own private networks. For on-premises, it means that the firewalls that were never open to internet may have to be first time open to public IPs. You have to allow internet traffic. Second thing is when you have the virtual network and you're setting up firewalls for that, network security groups for that, or advanced firewalls, you also, again, have to open to internet. The public IPs of Azure are documented, but the public IPs by service are not yet available. We are actually making ways for that, so you're mostly opening to internet traffic. And then third, because Azure services are available on public IPs and your data resides with Azure services, if any of your insiders, of anyone with credentials, go out of your network perimeter, they can get access to that data. And since cloud really runs on the trust that you give to your end users for your data, that's trust breached, right? So we take that threat very seriously, and we are committed to giving you private connectivity for your services, most of Azure services, and we think that all of the Azure services, in fact, should be in the VNet. You've seen momentum around that. You've seen that momentum with some of the offerings that we have had in the last couple of years, and we are continuing to invest in this area. Now, if you look at our services, there's no one answer to really bring them into the VNets directly. The reason is it has to do really with how the services are built. Ideally, we want to bring all of the services as dedicated instances into your VNets. And we've been able to do that for some of our services. We spin up these services into your VNets, and they become really native part of your VNet. But there are many other services that are in a fully shared mode. We really can't pull them as dedicated instance. Examples are Azure Storage, Azure SQL, Cosmos DB, Key Vault. These are the data services that are fully scalable, giving you many of the past guarantees like geo-replication, where if we pull them into dedicated mode, we lose some of that magic. And they no longer become the highly available, highly scalable, highly performant services that you're using today. And so we really, because we can't get them into dedicated mode, we now have a second pattern of how to get private connectivity, because the data really can be out there on the public IPs, right? So the way to extend these services into your VNet is to lock them down to your VNet. So a pattern one where we are able to give you dedicated instances, and pattern two where you can lock down your instances so that they're private to your VNet. So let's start by looking at pattern one. In pattern one, we have the services that deploy directly into your VNet. The way you would do this is you would go to the Azure service and pick the virtual network in which you would want to deploy the service. And the service then starts a dedicated instance in your own virtual network. The service continues to manage the dedicated instance that's deployed in your VNet, which means that it monitors the instance for the health status, the scaling up and down, and anything else that they need to manage that service instance in your VNet. The advantage of really having the service right besides all your VMs and all your data sources is, A, you can actually put internal load balancers for a lot of these services, which means that you can actually have private IP. For example, if you're deploying a HDD Insight cluster, you can put an internal load balancer in front of it, and you can have internal facing IP for it. Similarly, app service environment, and so on. What does that do for you? It means that your on-premises need not be open to internet IP ranges. You're now just connecting to your private IP. Your VMs that are sitting inside the same VNet that need to talk to app service environment or HDD Insight, they really don't need public IPs to talk to them. And more importantly, when these services are compute services working on data, they need to really reach into your on-premises, you don't need to have your on-premises open inbound to public IPs. Everything becomes part of your private network. Isn't that beautiful? I mean, we have quite a few services, and it should be solving all your problems, right? There are a few gotchas, though. Once a service subnet is in your VNet, that becomes part of your secure perimeter as well, which means that everything that happens in that subnet is now as important for you as your other VMs, as your other perimeter boundaries. Let's take a look at some of the things that you should be aware of. So once the service starts deploying, there is a service control plane that initiates inbound management traffic, ports and IPs open for managing the instance in your VNet. So since the service control plane has a public IP, they're going to create a public IP to reach into your VNet. So that's one. And then once they get to the public IP, most of the services actually need a few IPs and ports open. And we don't have that prescriptive because it really depends on the way the services are built. And because of the inbound management traffic, a lot of the services cannot support force tunneling, which means that on these subnets, for a lot of our services, if you put force tunneling, you will break the inbound management traffic. That's asymmetric routing problem. If you have inbound, you can't really take the outbound the other way around because the reply gets blocked. So, and then the services also depend on other Azure services. So if you're deploying HDD Insight or App Service or Batch or any other injected service, these depend on other Azure services like storage, SQL, etc. And so you have to open your outbound as well to the services. So is all doom and gloom in this world? It's not, right? So the good news is we're working on it. For the public IP, we have now a new range of services that are coming up with not having the public IP at all. Ideally, we want all services to not have public IPs. We're not there yet, but that's a consistent pattern that we are driving towards. So you will, I'll talk through some of the services that today have that don't require the public IP. And in supporting the force tunneling and supporting NSGs in a way that you don't have to open to internet, let's talk about NSGs first. For NSGs, we started working on service tags last year, as you may be aware. How many of you are aware of NSG service tags? That's great. Service tags take all the public IPs of a given service and consolidate them as a list. And that is done by Azure. So when you take a network security group, in the destination you can say, I just want to give the service name. And when you give the service name, we take care of the IPs. And you're not opening to all of the internet. You're only allowing that particular service control plane. Okay? So for some of the services, we now are beginning to have management tags. And so you'd have to put them as the first rule on the slide. In the inbound path, you'd have to put that as a source. And then for the outbound traffic for NSGs, we now have many, many tags since last we announced service tags at Ignite last year. And you can use all of those, a combination of those, to solve the outbound requirements for the injected services. And for the routing, we still do not have a good solution. But if for the services that do not have a public IP, that do not need a public IP, you could route traffic and you would not be impacting those services. We are setting a tone to that pattern, so hopefully more and more services will fall through it, which means that one day, very soon, you would be able to force tunnel in the deployed service traffic and you wouldn't be impacted. It's not the case yet today, but you'd have to double check with the service requirements to make sure that that's the case, because force tunneling is supported for some, and it's not for others. So some new announcements for the injection deployment into VNet scenario for the services that are directly in your VNet. We now have a firewall that just went GA. It's an advanced firewall that can support FQDN rules. Azure SQL managed instance, that is SQL as a pass in your VNet. It's a very powerful service, and I hope you've given it a try. If not, please do give it a try. It lets you run SQL in your own virtual network. And Azure Container Instance went preview recently. It lets you deploy containers into your VNet. You can have all advanced capabilities of the VNet, like the private network capability, as well as access resources, be those in your on-premises or the resources that are secured to virtual networks. Azure Web Apps is now in preview as well. You should start seeing it in a few regions very soon. The announcement is still not yet there. With the web apps, you're familiar with App Service Environment. A lot of you are actively using it. App Service Environment has been the dedicated model in which we have supported apps. With the web apps, we are now moving to the consumption model, but integrated with your VNet. So if you actually deploy web apps, you can now have native VNet integration and also access the resources that are available over ExpressRoute or over the ones that are logged down to your VNet. Okay? So let's look at the pattern 2, which is for the multi-tenant services. With the pattern 2, the services are not in your VNet, but your critical data is. How do you go about securing it? And that's all your business trust is, right? Like that's all your critical data is. So how do you go about using that in a private way? The answer to that has been the announcement that we made at Ignite last year, Service Endpoints. How many of you are actively using Service Endpoints? Yay, that's good. That's about 20 or 30% of the audience. And we hope to see more hands up. We were talking to some of the customers, and one of the quotes that's quite memorable personally is, we asked, is Service Endpoints important for you? And they said, it's not important, it's quite necessary. And so what is Service Endpoints? Service Endpoints lets you lock down the critical Azure resources to your virtual networks. Any of your data resources, be those on storage, SQL, Cosmos DB, a data lake store, or anywhere else, you can lock them down to your VNets. Service Endpoints extends the identity of VNet to the service. You can secure your critical resources to your VNets, and the reason why it's only your resources is Service Endpoints is to a service. So you set up a Service Endpoint to Azure Storage, switches the source IP to private, and sends your VNet information to the other side. So now the other service is aware that the traffic is coming from your VNet, and you can lock down your particular resources to your virtual networks. The traffic will remain on the virtual network, on the Microsoft backbone, for anything that's initiated from the VNet to the service with endpoints. And this is the full list of services that we have today supporting Service Endpoints. And again, since Ignite last year, we've had many, many services show up. Please do use them and secure them to your VNets. And we do have more coming up. I don't have it on the slide, but we will also, ADLS v2 would be supported, and ADLS also would be coming, a data lake store will also be coming soon. So if you're using endpoints, how do you really set it up? And I want to make sure that there are some gotchas that I want you to be aware of, because it's critical that you get the security right. And it's also that some of the service resources, as we've seen them, have had existing firewalls, existing settings. So we are learning from our customers. So here are some of our learnings this past year. If you have a normal resource, and if you haven't really secured it one way or the other in the past, any of the existing firewalls of that resource, the way you turn on service endpoints is first you go to your subnet, turn on the service endpoint, you pick the service, and put it on a subnet. And then if you look at, then you go to the resource, you pick that virtual network by the name, again, not by address space, because your private address space is not unique. Service endpoints will send the VNet information to the other side, which means that you're picking your virtual network by name and locking it down to the VNet, the resource to the VNet. But if you're using resources that have existing firewalls, there is one scenario that you need to be very aware of. If your resources are already locked down to public IPs, examples are SQL, right? SQL services have had public IP firewall for a very long time. Likely a lot of your organizations are already using public IP firewalls. If you do have public IP firewalls, please do not turn on service endpoints directly, because that will switch the private traffic on. It means that it will break the connectivity. So the recommended step would be to go turn on a setting in a lot of these services for SQL and databases that supported firewalls in the past, that is ignore missing service endpoint. There's a flag at the bottom that you can see. Turn that on, and that lets you add the virtual network before you turn on service endpoints. It will ensure that you have both the rules, the public rule and the private rule available. You will turn on the service endpoint, switches the traffic to private network. You can come back and remove the public IP. And this is only one-time migration if you have databases that are on public IP space. You don't need it otherwise if you are using resources that are LAVOL or haven't used firewalls in the past. And finally, whenever you set up your resources, please do make sure that you're turning off LAVOL settings or LAVOL Azure Services settings, because these are pre-existing settings for us. And when you turn on virtual networks, we want to make sure that the traffic remains on your secure networks. So always go back and please make sure that you're turning them off. So now I want to talk about how do you scale your workloads with service endpoints. This has also we are looking at your workloads. So we've been learning how you deploy your networks with service endpoints. And so I want to share some of those learnings. On day 0, you may start with a VNet and lock down your account or a resource to that VNet. To do that, you go and turn on the service endpoints and lock it down from the account point of view. But if you are bringing up a new subnet, you have to turn on the service endpoint on that subnet again and lock it down on the resource again. And if you have peered a VNet, you do the same. All of this should be done by the name. And please do toggle selected networks as and when you're adding the private networks. And then if you're bringing traffic from on-premises, this is very important and one of the frequently asked questions that we have. If you have traffic coming from on-premises, it will not, you cannot tunnel the traffic, or you can't take it from service endpoint some way or the other to the other side to be logged over the virtual network. You can't take it via gateway subnets. The traffic will continue to flow over the express route peering. Now, peering has changed in the past year. As you're aware, we used to have public peering that has now moved to Microsoft peering. With Microsoft peering, you have NAT in your own on-premises. So if you're familiar with your NAT IPs, please do put the NAT IPs in the IP firewall section of the firewall. It's not the virtual networks part, it's the IP firewall. You take the public IPs of your on-premises and set up a rule to allow those IPs. And we highly recommend actually using service endpoints on the VNets alongside with Microsoft peering, because with service endpoints, your traffic will remain on the backbone for at least the virtual network part of it. It means that it will not be sucked back to on-premises, and you will not have the extra latency. And with Microsoft peering, when the routes are advertised back, from Azure public IP ranges, the traffic will still remain on our VNet boundary even if we read those ranges back with BGP. Okay, so and if you have traffic coming from internet, again it's the same thing. You would take the IP firewall, add the IPs from internet, and so net you have to, if you're doing one-time migration, make sure all your networks are there, turn them on, and put deny all. But as your networks are growing, please do turn on service endpoints. Please go back and do add them in the resource rules on the other side. And before I move on, actually, I do want to say that some of you may also have thought about the service traffic. I didn't include slides for that because it's a complex topic in itself. If you lock down your storage accounts or Cosmos DB or Key Vault to the VNet, it means that other Azure services that are sitting outside your VNet cannot reach those resources. It means that, for example, a storage account that's locked to your VNet may not be reached by a backup service, or a Key Vault that's locked to your VNet may not be reached by data services for storage encryption at rest, or Cosmos DB encryption at rest. For those scenarios, there are specific workarounds of how you would get the traffic working. Please do refer to our documentation, and I'll be around after the session if you have any questions on that. But that's a topic in itself, and if you want me to do another session at a different point in time, do let me know, and I can cover that offline. So if you look at the range of virtual network and the Azure services, now we have the pattern 1, which is services that deploy directly, and pattern 2, services that lock down to your VNet. You can mix and match these, and that's how we would want you to use. You can deploy all of the services and put a service endpoint on those subnets and lock down your critical resources to the service subnets as well. It may be important if you're spinning up containers. It may be important if you're doing web apps, which is a LOB app, right? So we do support that, and you can continue scaling. Once you set it up, as you bring more services, keep adding all the service subnets on the resource side. Moving on, so if we now shift our focus to the virtual network part, when you turn on service endpoints, what's really happening with your virtual network? You turn on service endpoints, but you really haven't secured the boundary of how you access storage or SQL or Cosmos DB. They still have public IPs. They still have the public DNS. So what happened to your firewalls? What really happened to your on-premises firewalls? The answer to that is for network security groups. Last year, we announced service tags, as we just talked about it. Service tags take all the public IPs, and we maintain the public IPs, so you don't have to worry about the change of the IPs. You can deny all the outbound traffic and just allow traffic to these specific services. And from on-premises as well, we are now publishing these IP ranges with a special JSON file. So you can take these IPs, and these wouldn't change as often as what you see in the normal public IP address files that you see that we've had for many years. Now, moving on to a different challenge for your VNet. You've put service tags, you've put the accounts in the secure to the VNet. Is your data still in a trust zone? Is it fully secure on the cloud? There is still one loophole, right? Which is somebody from your VNet who has access to the VM in the VNet can read your corp assets that are logged down to the VNet, the storage account, let's say, and they can write to a different storage account that they own. Today, we are not able to prevent that with just the service tags, because service tags connect to all of storage, not to specific accounts. So how do you go about addressing this concern? One option is to use appliances, either the third-party appliances or the Azure firewall that we recently announced. You can forward all your traffic to the appliance and set up FQDN filtering there to ensure only your corporate accounts can be accessed. And to secure your data, we recommend that you turn on service endpoints on the appliance subnet, lock down your resources to the appliance subnet. Okay? So that way you have VNet level security as well as the resource level security. And once you also put that in conjunction with the NSG service tags, really none of the insiders can can really access unauthorized accounts. Okay? We do have an announcement to make, which is much more efficient if you're worried about the centralized management of appliances. We are very glad to announce service endpoint policies. These are the policies that you can set on your virtual networks with service endpoints. You can give very easy rules to say, I want to allow these particular accounts or all accounts in a subscription or all accounts in a resource group in a particular subscription. And over service endpoints, we are only going to give access to these listed accounts. All other accounts will be denied access. So combined with NSG tags, the service endpoint policies can really give you that granular control over your data in the cloud. So we have this available for Azure storage for West Central US and US West 2. We will expand that in preview mode to more regions in the coming months. So please do give it a try. And so how to layer this with NSG? So let's take a quick look at the scenario. If you have NSGs open to all of storage, and if you turn on service endpoint policies, because the network security group is wider than the endpoint region locations, because endpoints today, if you take storage, they only apply to geo-pair regions. Okay, so let's say you take West Central US, it applies to West Central US and US West 2. Service endpoint policies will protect traffic in these two regions, which means that nobody can access unauthorized accounts in these two regions. But if you set NSG wider than these two regions, it is possible to get to those other accounts. We highly recommend that you reduce the NSG scope to the regions that you absolutely need and to get the maximum data exfiltration protection. Okay, so let's do a quick demo. I want to show you how endpoint policies work. All right, so here I have a VNet that I've set up and a subnet. And I have service endpoints turned on for the subnet. The scenario I want to show you is I want to keep access of this VNet subnet only to a corporate account or my own account that I'm allowing. I don't want the VM to go access an unauthorized account, right? So if you look at the storage accounts, this is the account that I want to allow access. Since we talked about service endpoints, let me share quickly how to turn on service endpoints as well, the lock security with service endpoints. So we can go to the virtual networks blade, virtual networks and firewalls blade, as you can see here. You will go to selected networks, pick the virtual networks, pick the VNet and the subnet. If you don't have endpoints, we do allow you to set up endpoints from this menu. And you see the firewall menu here. This is where on-premises IPs or internet IPs will go. And the exception list is basically how you would give access to other Azure services. Okay? We'll not complete those steps in this demo, but for future reference, please do take a look at the exceptions as well as firewall. All right, so we have saved the firewall rules. Come back to the VM in the VNet. So this is one of my VMs in the VNet. Let's take a look. This is the other VM, so let's see. Okay. So I have a couple of different accounts that are being accessed from this VM. This is the valid account that we logged down to the VNet. And this here is your insider who may have access to that VM, right? So this account is logged to the VNet, and I'm able to access it. So we can see there's a file, and if you click download, you can access it, okay? And here's another account. This is not something that you authorized, but as you can see, it can also be accessed over service endpoints. And moreover, I can copy this and take it to that unprotected and internet-facing storage account. So this is what we call the data exfiltration. And to help solve that, so now let's set up service endpoint policies. Okay, so service endpoint policies are a top-level resource like network security groups. So if you type endpoint policies in the portal, you will see the menu. I want to show you the creation flow. I have one set up, but I want to show you how to set them up. So I pick the resource group. Let's give it a name. Okay. And in the policy definitions, you can either add a single account or all accounts in a subscription or all accounts in resource group. Just for simplicity, I'm going to pick all accounts in a subscription. I pick the subscription in which my storage accounts are in, and I'm adding that. Review and create. All looks good. Let's go ahead and create. We have that available. And if we go to associated subnets here, we have none set up. So we can go back to the virtual networks, click on the subnet, and associate the policy. So you can associate multiple policies. For now, I'm going to pick one and save. So effectively what we have done is on your virtual network, we are now limiting access only to your storage account. Let's make sure that got applied. That's good. Back to the VM. Let's refresh. And this is the valid account. Sometimes it takes a few minutes for the policies to go through, so I'm going to try it again. Yeah, so you can see your container. Now let's look at the other account. There we go. So the access is denied for any unauthorized account, and you can only limit access to your own accounts. And this is done natively in the platform over the service endpoint policies, service endpoints. So please do give it a try, and hope you like it. All right. So we covered how to secure access for Azure services in your VNets. The key takeaway for this section is, as Azure services are being used, as you bring them into your VNets, think them as a new perimeter that you have to deal with. And we have a couple of different mechanisms And please pick and choose one of the mechanisms, whichever is available and is the right thing for your service requirements. And you can continue layering as you go with a mix of services. With that, I would like to give the stage to Mario.
Thank you, Anita. Yeah. Great session. Yeah. Hello, everyone. Yeah, I would like to start to share with a story. A customer of mine who was asking for some consulting on network security. He had a very particular approach with respect to security. For him, he thinks that everything within their own network was trusted. For him, everything within the network can be accessing any of their other resources that they have in the network. So I asked this customer, so what's the security that you're actually applying into everyone that is accessing your resources? Let's say, what happens if someone tries to access your database? What this customer said, it's actually a quote for him, is that that will never happen. I will never actually share the password for anyone else. So having said this, I really wish that everyone has a similar approach, and I really want that no one actually has any potential threat that can actually compromise your network. But I really think that the current landscape of security can give you a lot of trouble. Like, for example, if you, for any reasons, you have any phishing within your own personal within your network, or maybe you have maybe a network admin that maybe is leaving the company, and maybe he can take the passwords with him and maybe do something within the network. You can have many different scenarios where this can actually go wrong within your network. And of course, you have at the end the most pessimistic story, which is what happens when someone actually has the password in one post-it in front of the workspace. So having said this, and I really wish that anyone never had these problems in your network, but there's a certain collection of best practices that we can recommend to secure your workloads within your network and to give you better protection in case of something goes wrong within your network. So I'll start with the first one, which is how to protect the access from the internet. For any traffic that is coming from the internet, there's a certain common set of threats. The first one is DDoS attacks. This one, it's basically whenever somebody's trying to compromise the availability of your service, they can basically do a specialized type of attacks to your network, and they can compromise your workloads. So for that, we have a set of recommendations and, of course, a product for that. We also have the second threat that can potentially damage your network, which is the web application vulnerabilities. For this one, I think the key piece here is that not everyone has the most secure personal when you're developing applications, and sometimes we are subject to create certain common flaws within your network. So I'll talk about this too in a moment. The first one, we have the best practice recommendation. We have DDoS defense. It's battle-tested products. We're using this within our own products. You can use it as well. For everyone, we're giving a basic DDoS protection. It actually has the same mitigation mechanisms that we use for our own services. But you can also have a standard version that gives you your own control over your own network. What this gives you to you as a customer, it's better telemetry within the attacks that your network is actually getting exposed. You'll get continuous monitoring, and we'll actually learn about the patterns that your applications are suffering. So for example, if any of your applications have a certain amount of throughput, we'll notice that whatever is regular or normal for your applications, and start the mitigation right when we notice that something is changing. So this is one of the options. Just a little bit of the details on what's the news announcements on DDoS protection. We have a lot of new functionality on this approach. For the standard SKU, the first one is we have a lot of telemetry about what's actually getting access into your network. We give you a lot of data, and whenever something is actually happening or any mitigation is triggered, we give you a snapshot where you can actually see how the attack is actually happening. You can actually integrate these logs within your own mitigation systems so that you can probably have a more proactive method for whenever someone is trying to compromise your service. The second benefit of the standard DDoS protection, It's a rapid response. It's basically a specialized call channel where you can raise a support ticket, and based on your DDoS protection plan, you can actually ask for some specialized expert to actually provide assistance whenever something is happening within your network. So if for any reason you have a workload that it's exposed to the internet and you're being suffered with a DDoS attack, you can actually just raise a support ticket, and they will be within 15 minutes actually engaging with you and trying to mitigate if anything is happening for your workloads. And lastly, it's integrated with Azure Security Center. Whenever you're using Azure Security Center, you'll see that you'll have a best practice recommendation to use DDoS attacks for any exposed workload to the internet. The next one is, it's about common web vulnerabilities. I'm guessing every one of us has a certain amount of developers that are building new web applications. For any of those that has new applications, and of course you trust your developer teams, maybe they are building very robust and trusted applications, but maybe sometimes as you're scaling in the cloud, you're bringing some applications that are vulnerable to different set of common attacks within the web HTTP, HTTPS type of traffic. The first one is cross-site scripting. What happens when someone actually creates an application that someone can steal the tokens and maybe access different parts of the application. And of course, we have SQL injection as well. What happens if someone doesn't have the right parsing of the inputs, and maybe it's actually exposing some of the data that we have internally and maybe actually compromising the data that we have internally. So for that, the recommendation is to use a web application firewall to mitigate any possible or potential threat that you're bringing to your workloads. What this will give you is the ability to bring more applications with a peace of mind that, yeah, you have a layer of protection that it's actually giving you a common set of policies. And even though you might scale at a different rate in the cloud, you will not actually be suffering from anyone bringing any of those common vulnerabilities to your environment. And of course, this is also integrated with Azure Security Center, and it has logging enabled within Azure Monitor. You'll be able to see all the telemetry from the web application firewall. The recommendation is not only to use the product from our side, you can also use any other third-party network virtual appliance that has the same capability. At the end of the day, what you want for your network is just to have a layer of protection for common web threats that might be reaching into your network from internet. Just a little bit on the announcement, we had a lot of features that were added recently. One of those is availability across multiple ACs. Now you can deploy the application gateway or the WAF and have it available across multiple ACs. This, of course, will give you more availability for your service. It has auto-scaling option. Whenever you set up as an auto-scaling option, it can grow depending on the bandwidth or the throughput that you're processing on the application gateway. You don't have to worry about growing up and down. Of course, you can set it manually. You can put it in a fixed mode and actually consume only the amount of nodes that you want to actually give you for your network. But if you're really willing to try it, you can actually set it as auto-scaling. It might give you some benefits for better cost-effective factor. And of course, this also has the ability to have a static BIF. You can actually have a fixed IP for your application gateway. It has additional benefits. One of those is you can have a better performance when it comes to deployment. It's actually reduced 75%, so in less than 5 minutes, you'll have an application gateway. So that will give you a little bit more scalability whenever you're growing your applications. If you need to keep adding more WAFs into your network, that's a good solution. And also, it has less than 40 seconds for provisioning for application rules. So this is the first two recommendations for any traffic that is coming from the internet. I'll have a diagram just for reference here, a little bit of recap on all the options that we're bringing into the picture. And this is how the first layer of defense is the DDoS protection. The second layer of defense is maybe a web application for or workloads that are exposed to the internet. And of course, we have covered protection to services with service endpoints and service endpoint policies. So this is just a little bit of recap. I'll keep adding into this diagram so that we see the picture on where every one of those features and products fits within the problems that we're describing. Now, coming into the VNet, like I said at the beginning, the VNet might or might not be your trusted boundary, but having a VNet that it's fully exposed to everyone might give you a little bit of trouble whenever somebody accesses one of the VMs and maybe for some reason can access the database directly from that VM. Maybe you want to have a best practice for that and not really provide full access to anyone within the VNet. This applies not only to the VNet, but also to the on-premises. Remember, we expand the context, and every access from your on-premises can come through any of the options that we have, Express Route and VPN gateways. And any of those traffics, if you happen to have maybe a branch where anyone can compromise a workstation, so you might want to think about how your security posture is for that type of traffic. It's not a good recommendation to trust any traffic that is coming from on-premises if you think it's not the right solution. So at some point, you have to apply something that it's within the network security area called as a zero trust model, which is if a VM is in your network, just give it access to the things that it needs to have access from, nothing else. If you have a database and it only needs access from your application layer or your application tier, don't give full access to the rest of the network. Now, what's the benefit of this type of approach is whenever someone compromises any jump box or any other web application or maybe something else, you will not be compromising your database just because you have fully open network connections. So for this one, there's two types of threat. The first one is unrestricted inbound traffic. So we can have multiple layers within the network, and maybe just because someone is reaching into your DMZ, that doesn't mean that from there they can go directly into your most critical workloads like your databases. The same happens for traffic from on-premises. If somebody actually gets access from your network within your on-premises, that doesn't mean that they can go directly into your databases within the cloud or maybe in your own data centers. The last one is untrusted outbound traffic, and I think I'm going to cover all of the options that we have for that at the end. So let me go into details. What are the options that we have to secure your network traffic within the VNet? Well, we have a lot of options, and the first best practice that we can give to everyone is have a good segmentation for your network. The good segmentation means that you can actually group the VMs and define the VMs and how they want to access and interact with each other. Just because someone can bypass your firewall on your on-premises or someone can bypass the web application firewall for a web application doesn't mean that once they are inside your network, they can access everything. If you have such a posture, you might get compromising the access to the different places, and you'll make it easier for anyone to basically expose all of your network. So for this one, we have one feature called application security groups. We don't have to make it hard. What we believe is that you can make it an easier segmentation within your network. You can group the VMs in whichever way you like. You can use it for tiers, for applications, modules, systems. It's really how you want to express your network architecture. Now, how we use it is you just give it a name, and that name can be used to group the VMs and tag the VMs and where they belong to. Now, by having this segmentation, you can bring multiple applications into the cloud, and they don't have to trust to each other unless you want them to trust. So what that means is that in this diagram, for example, you can have two applications with 3 tiers. If someone, for any reason, has access to one of those VMs and has access to the web servers, that doesn't mean that it's going to have access to the database servers. It doesn't also mean that it will have access to the rest of the applications. So in this mode, you will safely be scaling with new applications in the cloud, and you will not have any problem with having if for any reason you have one of web. Again, I wish no one has this problem in their network. But if for some reason you're bringing one application that it has a certain amount of vulnerabilities that someone can exploit, that's not going to compromise the rest of your applications. And you can have different environments for that. So what this will give you as a peace of mind is that you will have maybe your prod environment separated, maybe your dev environment separated, maybe your test environments in a different location. So this type of segmentation will give you the confidence that the access will not expand the rules that you have defined for them. We also have service tags. This is, of course, Anita already mentioned it. It's just for all of the services that we have, so you can narrow down the access to only the services that you need to. In this one, we have a special mention to, we have a new tag that we're going to browse it maybe on the demo. It's called Azure Cloud. We have some customers that are restricting outbound to the internet, and they like to use only the data center's IP. So they trust somehow the IPs that are on Azure, but nothing else. It's not an optimal solution, but it's one option that will simplify for anyone that is only using NSGs for restricting outbound. It will simplify a lot the configuration. And of course, it has integration with logging. We have NSG flow logs. We have a lot of integration with all of the flow logs with different third-party tools. What this gives you is full visibility on the traffic. All the VMs that you have within your VNet, you can see the toples, you can see the traffic, you can see what's denied, what's a load. And of course, on top of that, you can build your own analytics solutions. You can actually make super smart threat intelligence. On top of that, you can analyze the traffic and maybe see that the IPs belongs to Azure, maybe something is denied, and you can analyze maybe some patterns where your network it's getting hit by multiple nodes in the network. And of course, you can detect if something is compromised based on these logs. It's also integrated with Network Watcher for anything that is troubleshooting. You can troubleshoot the NSG with a lot of APIs that they have, and also it's integrated with Azure Security Center. They have one of the benefits for NSGs is that it's so simple and so it can scale so well because it's applied to every one of the nodes in the network. They can apply Git access policy. It's part of the Azure Security Center where you have a just-in-time policy. If you don't want a VM to be exposed forever in one specific port, maybe you just want that to give some access for a temporary time, you can use Git access policy to just access the VM for some time and then remove the rule at the end. It doesn't have to be a permanent policy. So that's a good best practice recommendation. Now, what the combination of NSGs and ASGs brings is a little bit of simplicity when it comes to segmentation within your network. And you can also combine all the policies so that at the end of the day, whatever you have in the network, it can have a single policy where you can view everything that it's trusted or not trusting. It doesn't matter if it's coming from on-premises, it's coming from internet, or within your network. You can basically ACL the access to the only things that you trust and you think are trusted for your applications. One of the key benefits of simplifying this and unifying into fewer NSGs, for example, you can combine all of those into fewer NSG rules, is that you can elaborate more advanced scenarios. One of those is a quarantine scenario. So in this example, I have a denied rule on the top, which I'm basically starting with a group that can be empty at the beginning. Maybe I don't have any VM that it's compromised. I don't really need to have a VM that is compromised. But maybe I'll just put a rule on the top that I know that it will be evaluated at the beginning. But if by any of the analysis that I have on the traffic, I notice that something is wrong with one of the VMs, maybe I have an antivirus integration, and maybe that VM for some reason gets notified as compromised, or it's unhealthy, maybe it has some malware. You can just simply tag that VM with the quarantines group. And what this will give you is no matter what the policy you have for that VM, it will be totally isolated from the rest of your environment. You can go and analyze what's going on with the VM. Maybe you put it back and just remove the quarantines group. So that level of simplicity will give you more powers into what are the things that you can leverage within your network. So just to recap and where the pieces feed into each other, we have, again, 2 layers of defense for traffic from internet. We have all the segmentation within the network. And now you have restricted access within your network so that all of your applications are isolated from each other, and you don't really have a plain network for trusting. And of course, we have service endpoints for the protection of Azure PaaS resources. Now, coming now to the outbound, we also think that you should have as much as possible only a restriction to destinations where you don't. If you have untrusted destinations, you should restrict it as much as possible. In this case, just to give a few examples on what usually happens with any of these threats occurs in any of the networks, if for any reason you have someone has breached into your VM, the first thing that maybe a malware could do is report back what's the status. I mean, that's a notice that maybe the first notice that someone might give to the internet. The second one is maybe they want to download some friends, maybe some additional tools to explore the network, and maybe something that I can use it for exploration, maybe a SQL client so that I can connect to the SQL database or something like that. And lastly, and more importantly, if they have access already to your data, they can probably take the data and put it into the internet. So that's an exfiltration concern as well. So for those type of threats, of course, NSGs might not be the ideal solution because NSGs are IP-based. And IP-based is probably not the ideal filter for outbound traffic. So for this, we have a lot of options and integrations. The first one is how the platform works. We have a routing behavior by default. Anyone that creates a VNet, their VMs can talk to each other, and we plumb the routes by default. Anyone that peers that VNet with another one, we plumb the routes by default. If you connect a VPN gateway or an express route circuit, we plumb the routes by default. Now, that doesn't mean that you cannot alter the routes and make it more user-defined. That's what we usually call user-defined routes. What it gives you is the power to route the traffic to wherever you want to, and maybe use any of the third-party virtual appliances to apply more restrictions on that type of traffic. One of the options is I want to route the traffic to a virtual appliance and maybe do an inspection on the packets, maybe do additional filterings, and especially for outbound, if the things that you know that you have to access to are FQDNs or domain names or any URL, then you probably want to filter based on the things that you know and not on IPs, because IPs might not be the optimal solution for that approach. So you can have this type of scenarios for restricting all the outbound to the internet. And of course, now we have another option as well as virtual appliances, which is Azure Firewall. It gives you the same capabilities. You can route the traffic to your Azure Firewall and have your most restricted policies for outbound policies, Azure outbound policies for internet. So this is all well integrated within the same products. And of course, combine this with service endpoint policies, and anything that is routed to the services and past services can also be secure as well. So at the end of the day, you want to go into a mode where anything that is going out, it's only going to the places that you trust and nothing else. Now, this might not be easy to achieve. Not everyone can actually go directly into this mode. So my recommendation is use any of the virtual appliances or Azure Firewall and enable some logging for some time, maybe a month, maybe sometime. So as long as you think that you have enough data that can give you the clues that what are the things that your VMs are accessing to. Now that you have that knowledge, because maybe the Windows updates happens every once in a month, maybe the certificates of your workloads are happening also every once in a month, then you'll have all of this data, and then you can plumb now more restricted policies on your firewall. So the best practices for that is always try to learn from your applications and then apply the policy, unless you really know what your workloads are actually accessing to. So for this one, the announcement for this Ignite, it's Azure Firewall is now GA. It's a fully native stateful firewall as a service. You don't have to worry about the scaling. It has a built-in capabilities for scaling and filtering the traffic in a layer 3 and layer 4 mode. So essentially, you can plumb the firewall and route the traffic and filter and apply your more restricted policies based on FQDNs. One of the recommendations for any of this type of modes is that you should put the Azure Firewall or maybe the virtual appliance into a centralized place where you can route the traffic and combine with multiple of workloads that you have in your network. It's not a good recommendation to have Azure Firewall for every single one of your applications because it might not be ideal from pricing perspective. But if you have complex environments like we were describing before, maybe a hub and spoke model or anything where you have a main VNet where you can route the traffic to, of course, you can combine UDRs, route the traffic there, and filter and centralize all of your outbound traffic to the internet. Now, you should apply this for any of your workloads that are the most critical at first, and of course, you can expand to the rest if you feel you could move to this mode. It's all already available, and please give it a try. And one of the benefits that you have for this one is centralized logging. You can send everything into one place, and of course learn from the patterns of your applications. And it's already integrated within the rest of the Azure ecosystem of products. So again, a little bit of recap. The inbound traffic, you have 2 layers of protection: DDoS, WAF. Segmentation within your network, service endpoints for past services. Now, if you go out, if you need to filter and restrict the traffic, please use any of the virtual appliances options or any of the Azure firewalls for your most critical applications in the cloud. So with this, I think we have covered the 3 options. We have covered how to secure your workloads, not only for past services, from internet, any of the common threats that you have in the internet, and also within the network with all of the tools that we have to support advanced scenarios. Let me see. I think I'm not going to have enough time for the demo. I'm just going to show one piece of the portal for to explain the simplicity of maybe this, the microsegmentation on Azure. So this is just, I think I'm going to cover just basics here. This is just a configuration of an NSGs with ASGs. So one of the steps that you want to do is just create your policy, and if you don't have many applications, you can actually combine up to 100 applications within the same network security group. Now, one of the benefits for using ASGs is that you really don't have to worry about IPs. It's just about namings. So the step number one is create your ASGs, which is the groups that you have. You don't have to have any single VM for that. It's just creating the monikers, the names. Now, once you have the VMs, you want to define the rules. And in this case, I have one 3-tier example. I want to allow access from internet to our web servers, from web servers to app servers, and from app servers to DB servers. You don't have to make it super complex as long as you have the knowledge of your topology. And of course, you can replicate this and scale with multiple applications. Creating rules, it's very simple. It's integrated within the same NSG blade. So all you have to do is create a rule where you select multiple ASGs. Like, for example, I want to define that app service can talk to someone else. And it's just a matter of selecting the right application security group for that. So this is like app service to DB servers. Now, I'll take a moment here to explain a little bit of the options that we have on the service tags, because I think we didn't cover all the details. This is just to give you an idea on all the services that we have onboarded into IP tagging, and gives also the simplicity on how to ACL and create rules within your network. We have plenty of services. The one that I was referring a few moments ago is the Azure Cloud, but we also have plenty of services here. Some of those are meant to be for injected services, the ones that are dedicated for you. So for example, if you have app service environment, you'll have app service management. So you'll no longer need to open up your inbound either to internet or to a bunch of IPs and keep configuring IPs for that service. It might be very painful over time, and also it might compromise the SLAs from the service. So you might want to use one of the tags that actually has all of the IPs from the service, and you don't have to worry about that service scaling, because that tag will be already maintained by Microsoft, and it will already update your reference. So we have a few options: app service management. We have API management. Connectors are also a PaaS service that has inbound traffic, and gateway manager as well. So all of those will simplify your inbound story without having to be fully open to the internet. So, and then coming back to the VM. So step number one is creating the ASGs. So step number two is creating the policy. So once you have the policy, it's just as simple as going into the VM and then creating a tagging approach for your VM. Again, you don't have to worry about the specific IPs that this VM has. All you have to do is go into the networking blade of the VM, and you will be able to update the application security groups that this VM belongs to. Again, we have the same policy here so that we know how the policies apply to this VM. And all we have to do is go into this blade and select as many as we think. It's actually a multi-value group. And if we think it belongs to multiple groups, you can just select all of those. So this is just about the simplicity that we have on the network security. Let me go. So coming back to the presentation. I think I have only, okay. So just putting it all together, this is just a list of potential threats that we have discussed here. And maybe we actually refer to all of the products that might help you to mitigate or reduce the risk that you have in your network, and how to build and secure your applications. Now, depending on how critical your workloads is, it's the amount of tools that you have to use to protect them. An overview slide. This was already on the session with Joseph. It's just to place every one of the products into the right place, so that you know what's the right tool for depending on your scenario, and when to use one of those tools for your workloads. So the key takeaways from this session is we wanted to give you a list of best practices. It might be probably too much for what we cover within 75 minutes. But at the end, we want you to have at least the options that you can use within your network, and to know when to apply one of those patterns depending on how complex or not it's your environment. And also, We want you to actually have all the benefits from scaling in the cloud, so you can actually apply the same techniques every time you have a new application. Just, okay, I have my checklist of techniques that you have to apply based on your own requirements. And of course, this is a model that you can scale depending on the product that we have mentioned. Of course, it means that you have to create maybe additional resources or maybe reuse one of the existing configurations that you already have. But at the end, you can scale without any problem within using this collection of best practices. So, just recommendations. We're going to have a deep session on Azure Firewall on Friday. I think it's the one almost at the end, and that's going to be like super deep into how the firewall works and how to configure, how to actually make the firewall rules applicable, and maybe a deep integration with additional partners with the product. So if you're really interested on deep firewall capabilities, that's a good recommendation. And we have the rest of the sessions that we have from networking that are remaining for the rest of the week. Please don't forget to evaluate the session and give us all the feedback that you have for the session. Of course, this is also very valuable for us, and we'll take it into account for the next. So
we don't have much time, actually.
I know. If anyone has any questions, we'll remain within the area. So.
Thank you.